Just the fact that we have had such a big impact on almost every airplane that the Air Force has ever flown. If you look back to the Wright brothers, they sold their first airplane to then the Army Air Corps back in 1908 or whatever. It really wasn't usable. It wasn't until what is now AFRL stood up to really have some rigor into some of the processes, some of the material specifications, that it really became a usable tool for the military.
I would have to say my first interface with AFRL was 6 days after the plane hit the building in the Pentagon in September of 2001. And we were asked by the President, what can we do to win the global war on terror? To go do better research and engineering and development and move rapidly.
We really had a hand in the invention of aerospace composites, starting from carbon fiber and making that a usable material for airplanes, to making it affordable so that it could be used on a whole host of airplanes, and the impact that has had not only on the Air Force but really commercial aviation. You see it now on the 787 and the Airbus planes because of the investments made by the AFRL Materials and Manufacturing Directorate.
I think the most impactful technologies that AFRL is working on today that we'll see some impact in the relatively near future are in the areas of additive manufacturing, digital thread, robotics, especially in the area of cooperative robots. I foresee a future where we're able to tie all of this technology into the digital thread so we understand what's going on from the initial design all the way through sustainment and then feeds into the next program.
I guess one of the most critical technologies that we look to AFRL to provide us were improved sensors. We needed an awful lot of intelligence, surveillance, and reconnaissance in order to deter and defeat the enemy. And so the work that AFRL had done in size, weight, and power, it's always critical. The leadership has been able to reach into that passion and make that passion of the workforce really produce more than I think it could have just on its own. People are driven.
I actually learned a lot about the teamwork that they have at AFRL with the different directorates, especially air vehicle, the structures folks, and the manufacturing directorate people. And that was kind of a model for me, learning how to work with integrated process teams at Boeing.
They're some of the smartest people I know. It is just amazing, the creativity, the things that people come up with.
One of the things I really learned working with AFRL is that the program managers and the engineers and the scientists at AFRL are not just our customers, they're our collaborators, they're our co-developers of the technology. And that's really been important when we've run into problems, as you always do in development, in that they didn't take the stance of just being a customer. They dove in with us and helped us develop the technology, and also made sure that it was ready for implementation when it came to that time.
And so I think we've always been very fortunate in having laboratory leadership, and given that leadership, the culture of the laboratory in its civilian next level was able to flourish.
Their track record over the years, I think, has created a culture that not only attracts but also retains really good people.
We transitioned some stitched resin-infused landing gear doors for the C-17 program. That was a wonderful accomplishment. Later on the DARPA program that we worked with AFRL on, we were able to use out-of-autoclave composites and actual flight components and actually use those materials today. It was a wonderful activity.
AFRL really focused on SBIRs for F-35, for example, where we developed and implemented inlet duct robotic drilling. We also developed a RADS system, which is the robotically applied drilling system. That was implemented on the B-2.
We worked with Lockheed Martin to develop a cargo-sized airplane that showcased bonding the airplane together rather than putting it together with fasteners, that you can make very large parts to reduce the part count, reduce the part count by 90%, reduce the number of fasteners by 98%. And we went 18 months from starting the contract to flying a demonstrator. It was just tremendous.
One thing that I don't think gets mentioned as much is the work they've done in defining and establishing the use of MRLs, manufacturing readiness levels.
The AFRL and the partnership they have with industry, really bridging that valley of death has been a really good relationship. Being able to take some innovative technologies either out of S&T and then be able to take them across from 4, 6 to 7 and then ultimately see them put into production. It's just, it's very good.
So a few of the areas that we work closely with AFRL include the metals and the composites affordability initiatives. There's a materials and processes element of the integrated high payoff rocket propulsion technology program where AFRL and NASA work very closely over several years. I think we've made some really significant advancements in that area that's contributed both to the defense mission of AFRL and to the NASA mission.
So I think the roots of what we today call the digital thread, the model-based enterprise, what's starting to influence industry as Industry 4.0 and smart manufacturing, all traces its roots back to what Air Force did in the 80s and subsequent years.
There were major fabrication programs on metalworking, on all advanced metals, and working in conjunction with the metals researchers as well as the composites people and the electronics people, such advances as advanced composites, fabrication capability, microelectronics, samarium cobalt magnets.
But in general, aerospace is going to keep growing, and I think AFRL will continue to be a big part of that. One of the big advantages of an organization about AFRL is they see everything. So they see what everyone is doing, they have the landscape, and working with folks who have that vision and have that breadth of experience will always be important. But I think the outlook for aerospace in general looks very bright.
So where do I see the largest technology advancements coming from in the future? I really see the advancements coming from the integration of small businesses technology with integration with the OEMs, especially the major OEMs. So these small businesses integrated with major OEMs for requirements and guidance really creates an environment of innovativeness.
Because I really think that in the future, we're no longer in this environment where we're developing technologies in silos, if you will. The future is really like that enterprise-wide, all of the technologies somehow have to integrate, whether it's a digital technology or robotics, like somehow they're going to collide together. So I think that they're really pulling all that together and they're seeing that vision and we're collaborating in it. So it's pretty exciting to be a part of that.
What's that next revolution in military warfighting? And there's a whole lot of things in there that manufacturing is going to have to touch as well. It's not all about the cyber aspect of it, but it's the merging of the cyber and the physical, where Mantech and really the whole defense industry is going to have to move into.
I think what's going on now in flexible electronics is incredible. The way we're able to integrate on a flexible substrate, the needs that we're going to have just for battery power, for instance. What's going on in battery research and flexible electronics, I think, is a real game changer.
So I think what we'll see is literally an explosion of new capabilities, which are going to be challenges to manage and control, what with cyber threats, what with terrorism, but the opportunities are clearly there at a level which we have not seen, historically, and I think we're all going to be surprised what that produces capability-wise.
Congratulations, AFRL Materials and Manufacturing Directorate. By the way, Boeing just celebrated its 100th anniversary, so congratulations on yours, and let's keep going for the next 100 years.
Congratulations, AFRL. You don't look a day over 99.
Big congratulations to AFRL on the 100th anniversary. And even though I was not there when it was birthed, I wish you another 100 years of total success.
Let me say congratulations to AFRL, especially the Materials and Manufacturing Directorate, on this milestone of their 100th year anniversary. I know they have a fantastic history, and I know we can trace a lot of accomplishments in the area back to AFRL.
Congratulations, AFRL and predecessor organizations. I've been privileged to be part of you in one way or another, either as a civilian, as a military, as a civilian, later as a contractor, and you're a very special community, and the achievements have really been incredible.
So AFRL, congratulations on 100 years in the business.